Turning from testing to prediction, the confidence interval for the conditional mean. At a chosen regressor value, the fitted line gives the estimated mean and its variance has two readable pieces, a 1 over n term and a term growing with the squared distance from the mean of x. The interval is the estimate plus or minus a t, critical value times that standard error. One geometric feature to remember: the interval is narrowest at the mean of the data and fans outward as the evaluation point moves away, because information is densest at the center. And as the sample grows without bound, the interval shrinks to nothing. The conditional mean is eventually learned exactly. Predicting an individual outcome is a different task. The prediction error for a new apartment contains everything the mean interval had, plus the new unit's own error draw. Its variance therefore carries an extra term, the irreducible individual variation around the regression surface. That term is the mathematical signature of the difference between knowing the average and knowing one case. The prediction interval takes the same plus or minus form, with the extra one inside the square root. Mark the phrase on the page, irreducible width. The extra term does not vanish as the sample grows. Even with the regression line known perfectly, individual apartments scatter around it, and the interval must honor that scatter forever. The table draws the contrast in 4 rows. The confidence interval covers the conditional mean. The prediction interval covers an individual outcome. As data accumulate, the first shrinks to 0, the second to a positive constant. The first leans on the central limit theorem. The second genuinely needs normal errors, and roughly 95% of data points should fall inside a 95% prediction interval, versus essentially none for a tight confidence interval. Prediction intervals are always wider. In R, both intervals come from the predict function. Hand it new data and ask for the confidence or the prediction interval at your chosen level. The multiple regression version works identically, with the new data frame specifying every regressor. Here, an 80 square meter apartment with a 3,000 krona fee newly produced. Python wraps both intervals in one object. The getPrediction method returns a summary frame whose columns hold the mean's confidence bounds and the observation's prediction bounds side by side. The naming convention, mean bounds versus observation bounds, is precisely the conceptual distinction the comparison table just drew, now embedded in the software itself.